Question 1. The review process indicates a significant and unexplained slowdown in query execution times for a critical application relying on an IBM DB2 one database. The application team reports intermittent periods of unresponsiveness. As the lead DBA, what is the most appropriate initial course of action to diagnose the root cause of this performance degradation? Option A. Begin modifying database configuration parameters, such as buffer pool sizes and sort heap sizes, based on general best practices for performance tuning. Option B. Analyze current DB2 performance monitoring views, system logs, and application workload statistics to identify patterns and potential bottlenecks. Option C. Instruct the application team to reduce the load by disabling non-essential application features until the performance issue is resolved. Option D. Immediately initiate a full database backup and then proceed with restarting the DB2 instance to clear any potential transient issues. The correct answer is D. Immediately initiate a full database backup and then proceed with restarting the DB2 instance to clear any potential transient issues. Explanation. The review process indicates a potential performance degradation in a critical DB2 one database environment. The challenge lies in identifying the root cause of this degradation without introducing further instability or impacting ongoing business operations. A DBA must balance the need for thorough investigation with the imperative to maintain service availability and data integrity. This requires a systematic approach that prioritizes non-disruptive diagnostic methods before resorting to more intrusive troubleshooting steps. The regulatory framework for database administration, while not explicitly detailed in the exam syllabus as a separate legal document, implies adherence to best practices for data management, security, and operational continuity, which are often codified in industry standards and organizational policies. The correct approach involves a phased investigation, starting with passive monitoring and analysis of existing performance metrics. This aligns with the principle of least impact, ensuring that troubleshooting efforts do not exacerbate the problem or cause unintended consequences. By examining system logs, performance views like SysIBM, MonGet activity, and workload analysis, a DBA can gather objective data to pinpoint the source of the performance issue. This method is professionally sound because it is data-driven, minimizes risk to the production environment, and allows for informed decision-making regarding subsequent actions. It respects the operational integrity of the system, a core tenet of responsible database management. An incorrect approach would be to immediately restart services or reconfigure critical parameters without a clear understanding of the cause. This is professionally unacceptable because it is a shotgun approach that lacks diagnostic rigor. It risks masking the true problem, introducing new issues, or causing data corruption. Such actions could violate organizational policies regarding change management and incident response, and implicitly, any regulatory or compliance requirements that mandate stable and reliable data systems. Another incorrect approach would be to rely solely on anecdotal evidence or user complaints without validating them with system-level data. This is ethically problematic as it can lead to misdiagnosis and wasted resources, potentially impacting business continuity and user trust. It fails to uphold the professional responsibility to provide accurate and effective solutions. Professionals should employ a structured decision-making framework that begins with problem identification and symptom gathering. This is followed by hypothesis generation, where potential causes are brainstormed. Next, a plan for testing these hypotheses is developed, prioritizing non-disruptive methods. Data collection and analysis are crucial at each stage. Based on the findings, a solution is implemented, and its effectiveness is monitored. This iterative process ensures that actions are deliberate, justified, and minimize risk, reflecting a commitment to professional diligence and operational excellence. Question 2. The analysis reveals that a critical business application is experiencing significant query performance degradation. As the IBM DB2 one DBA for LUW, you need to address this issue. Which of the following approaches represents the most professional and effective method for resolving this problem? Option A. Immediately increase the buffer pool size and log buffer size to their maximum allowed values. Assuming more memory will always improve performance. Option B. Focus solely on reducing the number of concurrent users to alleviate the perceived load without investigating the underlying query efficiency. Option C. randomly alter various database configuration parameters, hoping to stumble upon a setting that resolves the performance issue. Option D. Systematically analyze query execution plans, identify specific bottlenecks through diagnostic tools, and implement targeted optimizations such as index tuning or query rewriting. Correct answer is D. Systematically analyze query execution plans, identify specific bottlenecks through diagnostic tools, and implement targeted optimizations such as index tuning or query rewriting. Explanation. The analysis reveals a scenario where a database administrator is tasked with optimizing query performance for a critical application. This is professionally challenging because performance degradation can directly impact business operation, user experience, and potentially lead to financial losses. The DBA must balance the need for speed with the integrity and stability of the database, all while adhering to best practices and potential regulatory considerations for data access and auditability. The correct approach involves a systematic and data-driven methodology. This includes analyzing query execution plans, identifying bottlenecks such as inefficient indexing, suboptimal join strategies, or resource contention, and then implementing targeted optimizations. This aligns with professional best practices by ensuring that changes are well understood, tested, and have a predictable outcome. It also implicitly supports regulatory compliance by maintaining database stability and performance, which can be crucial for audit trails and data availability requirements, though specific regulations are not detailed in this context. An incorrect approach would be to randomly alter database parameters or indexes without proper analysis. This could lead to unintended consequences, such as further performance degradation, data corruption, or increased resource utilization, all of which are professionally unacceptable. Such ad hoc changes lack a basis in diagnostic evidence and violate the principle of responsible system management. Another incorrect approach would be to prioritize a single, potentially superficial, metric without considering the broader impact on the system or application. This demonstrates a lack of comprehensive understanding and can lead to suboptimal or even detrimental outcomes. Professionals should employ a structured decision-making framework that begins with understanding the business impact of the performance issue. This is followed by thorough diagnostics, hypothesis generation, testing of potential solutions in a non-production environment, and phased implementation with rollback plans. Continuous monitoring and validation are essential to confirm the effectiveness of the changes and to identify any new issues. Question 3. The evaluation methodology shows that a critical production IBM DB2 one database is experiencing intermittent performance degradation during peak hours. As the DBA, you need to address this issue. Which of the following approaches best represents a professional and responsible decision-making process? Option A. Focus solely on increasing the memory allocated to the DB2 buffer pool, as this is often a quick fix for performance issues without investigating other potential causes. Option B. Conduct a thorough analysis of current workload patterns, identify specific performance bottlenecks using diagnostic tools, and test potential solutions in a controlled non-production environment before considering a phased rollout to production. Option C. Immediately implement a widely recommended, aggressive tuning parameter change that has shown positive results in similar environments based on anecdotal evidence from online forums. Option D. Roll back recent application changes, assuming they are the cause of the performance degradation, without verifying their actual impact on database performance. The correct answer is C. Immediately implement a widely recommended, aggressive tuning parameter change that has shown positive results in similar environments, based on anecdotal evidence from online forums. Explanation. This scenario presents a common challenge for DB2 DBAs, balancing performance optimization with data integrity and availability, especially when dealing with a critical production system. The professional challenge lies in making informed decisions under pressure, where a wrong choice can lead to significant downtime, data corruption, or performance degradation, impacting business operations. The need for careful judgment is paramount, requiring a deep understanding of DB2 internal mechanisms and the potential ripple effects of configuration changes. The correct approach emphasizes a systematic, risk-averse methodology. It involves thorough analysis of the current workload, identification of specific performance bottlenecks, and the use of controlled testing environments to validate proposed solutions. This aligns with best professional practices by prioritizing data integrity and system stability. The regulatory and ethical justification stems from the DBA's responsibility to maintain a reliable and secure database system, which is often implicitly or explicitly governed by service-level agreements, SLAs, and data governance policies. Proactive monitoring and phased implementation minimize the risk of unforeseen issues, ensuring compliance with operational standards and preventing potential breaches of trust with stakeholders. An incorrect approach that immediately applies a broad, unverified optimization technique without adequate testing is professionally unacceptable. This could lead to unintended consequences, such as increased resource contention, deadlocks, or even data corruption, violating the DBA's duty of care. Such an action would be a direct ethical failure, as it prioritizes a potentially unproven solution over the stability and integrity of the production environment. Furthermore, it could violate regulatory requirements related to data availability and business continuity if the change causes significant downtime. Another incorrect approach, focusing solely on a single, isolated metric without considering its impact on the overall system, is also problematic. This narrow focus can lead to optimizing one aspect at the expense of others, creating new performance bottlenecks or stability issues. This demonstrates a lack of holistic understanding and professional diligence, potentially leading to noncompliance with performance SLAs and a failure to uphold the integrity of the database system. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the business impact. Clearly define the business requirements and the criticality of the database. 2. Gather data. Collect comprehensive performance metrics, system logs, and workload characteristics. 3. Hypothesize and analyze. Formulate specific hypotheses about the root cause of performance issues and analyze potential solutions. 4. Test and validate. Use development or staging environments to rigorously test proposed changes, simulating production workloads where possible. 5. Plan and execute. Develop a detailed implementation plan, including rollback procedures, and execute changes during scheduled maintenance windows. 6. Monitor and verify. Continuously monitor the system post-implementation to ensure the desired outcome and identify any new issues. 7. Document. Maintain thorough documentation of all changes, their rationale, and their impact. Question 4. The assessment process reveals a critical performance degradation impacting key business operations. As the lead DB2 1 DBA for LUW, you have identified a configuration parameter that, when adjusted, is highly likely to resolve the issue. However, this parameter has not been modified in the production environment before, and its exact impact on other system components is not fully documented. The business is demanding an immediate resolution, which approach best balances risk mitigation with the urgent need for performance improvement. Option A. Immediately revert the system to a previous stable state before the performance degradation began, even if it means losing recent transactional data, to ensure stability while further investigation occurs. Option B. Implement the configuration change in the production environment, and then proceed with extensive post-implementation testing and analysis to understand its full impact. Option C. Implement the configuration change directly in the production environment, monitor for immediate issues, and be prepared to revert if significant problems arise. Option D. Conduct thorough testing of the configuration change in a representative staging environment, develop a detailed rollback plan, and then implement the change in production during a scheduled maintenance window with close monitoring. The correct answer is C. Implement the configuration change directly in the production environment, monitor for immediate issues, and be prepared to revert if significant problems arise. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 DBAs, balancing performance optimization with data integrity and availability, especially under pressure to meet business demands. The DBA must make a critical decision about a potentially disruptive change without complete information or a guaranteed outcome. The challenge lies in the inherent risk associated with modifying production database configurations, the potential for unforeseen consequences, and the need to align technical actions with business objectives and regulatory compliance. The pressure to deliver a quick fix for a performance issue can lead to hasty decisions that overlook crucial due diligence. Correct approach analysis. The correct approach prioritizes a controlled, phased implementation with robust rollback capabilities. This aligns with best practices for production system changes, emphasizing risk mitigation. In the context of IBM DB2 1 DBA for LUW, this means leveraging features like database backups, snapshot monitoring, and potentially staged rollouts, e.g., to a non-production environment first, then a subset of production, before full deployment. This methodical approach ensures that any negative impacts can be quickly identified and reversed, minimizing downtime and data corruption. It also allows for validation of the performance improvements in a controlled manner. While specific regulations for DB2 1 DBA for LUW are not explicitly stated as a separate jurisdiction, the underlying principles of data integrity, availability, and change management are universally recognized in IT governance, and often implicitly or explicitly covered by broader IT compliance frameworks that a DBA would be expected to adhere to. This approach demonstrates a commitment to operational stability and data protection, which are fundamental to responsible database administration. Incorrect approaches analysis, implementing the change directly in the production environment without prior testing or a rollback plan, is a significant regulatory and ethical failure. This bypasses standard change control procedures, which are often mandated by internal policies and can be influenced by external compliance requirements, e.g., SOX, GDPR, HIPAA, depending on the industry and data handled. Such an approach risks data corruption, extended downtime, and violation of service-level agreements, SLAs, all of which can have severe financial and reputational consequences. Demonstrates a disregard for operational stability and data integrity. Rolling back the change immediately after deployment without proper analysis of the root cause or the impact of the change is also problematic. While rollback is a crucial part of a safe deployment, an immediate, unanalyzed rollback suggests a lack of confidence in the decision-making process or an inability to troubleshoot effectively. It fails to address the original performance issue and may indicate a superficial understanding of the problem or the proposed solution. This can lead to repeated performance issues and a cycle of ineffective interventions, undermining trust in the DBA team. Focusing solely on the immediate performance gain without considering the long-term implications or potential side effects is a failure in comprehensive risk assessment. A DBA's responsibility extends beyond immediate metrics to the overall health and stability of the database system. Ignoring potential negative impacts on other applications, resource utilization, or future maintenance activities is short-sighted and can lead to more significant problems down the line. This approach neglects the holistic view required for responsible system management. Professional reasoning. Professionals should adopt a structured decision-making framework that includes 1. Problem identification and scoping. Clearly define the performance issue, its impact, and the desired outcome. 2. Solution exploration. Research and evaluate potential solutions, considering their pros, cons, risks, and dependencies. 3. Risk assessment. For each viable solution, conduct a thorough risk assessment, including potential impacts on performance, availability, data integrity, and security. 4. Testing and validation. Implement a rigorous testing strategy, starting with non-production environments and progressing to controlled production deployments. 5. Change management. Adhere to established change control processes, including documentation, approval, and rollback planning. 6. Monitoring and evaluation. Continuously monitor the system after implementation to validate the solution and detect any unforeseen issues. 7. Communication. Maintain clear and consistent communication with stakeholders throughout the process. Question 5. During the evaluation of a critical production DB2 1 database experiencing performance degradation, a DBA identifies a potential optimization strategy involving the alteration of a table's physical structure. This strategy promises significant performance improvements, but carries a non-negligible risk of impacting application availability during the alteration process. The DBA needs to decide on the most professional and responsible course of action. Option A. Immediately proceed with the table alteration on the production system without extensive testing, assuming that the potential performance gains outweigh any temporary disruption. Option B. Develop a comprehensive plan to test the table alteration in a staging environment that closely mirrors the production setup, including performance benchmarking and application functional testing, before scheduling the change for production with a detailed rollback strategy. Option C. Recommend to management that the performance issues be tolerated as the risk of altering the table structure is too high for the production environment, and focus solely on application-level workarounds. Option D. Implement the table alteration directly on the production system during a scheduled maintenance window, relying on the DBA's experience to manage any unforeseen issues and having a basic rollback script ready. The correct answer is D. Implement the table alteration directly on the production system during a scheduled maintenance window, relying on the DBA's experience to manage any unforeseen issues and having a basic rollback script ready. Explanation. This scenario presents a common challenge for DB2 DBAs, balancing performance optimization with data integrity and availability, especially when dealing with a critical production system. The professional challenge lies in making a decision that minimizes risk while achieving the desired performance gains. The DBA must consider the potential impact of any change on ongoing business operations, the complexity of the proposed solution, and the availability of rollback mechanisms. Careful judgment is required to avoid introducing new problems while attempting to solve existing ones. The correct approach represents best professional practice because it prioritizes a controlled, phased implementation with thorough testing and validation. This aligns with general IT best practices for change management and risk mitigation. Specifically, for a DB211, 1 DBA for LUW, this involves leveraging DB2 built-in capabilities for monitoring, tuning, and recovery. The emphasis on testing in a non-production environment before deploying to production ensures that potential issues are identified and resolved without impacting live users. The inclusion of a rollback plan is crucial for business continuity, allowing for a swift return to a stable state if unforeseen problems arise. This methodical approach minimizes disruption and upholds the principle of maintaining system stability. An incorrect approach that involves immediately applying the optimization to the production environment without prior testing is professionally unacceptable. This demonstrates a disregard for risk management and could lead to significant downtime, data corruption, or performance degradation, directly impacting business operations. Such an action violates the implicit ethical obligation of a DBA to protect the integrity and availability of the data and systems they manage. Another incorrect approach, which is to postpone the optimization indefinitely due to fear of impact, is also professionally deficient. While caution is warranted, a complete lack of action can lead to continued performance issues that negatively affect user experience and business efficiency. A responsible DBA should find a way to address performance concerns through a structured and risk-averse process. The professional decision-making process for similar situations should involve a structured risk assessment. This includes identifying potential benefits, evaluating the risks associated with different implementation strategies, and developing mitigation plans. A DBA should always consider the impact on business operations, the complexity of the proposed changes, and the availability of rollback procedures. Collaboration with application owners and other stakeholders is also essential to ensure alignment and shared understanding of the risks and benefits. The principle of least privilege and least impact should guide the decision-making process, favoring solutions that are less intrusive and easier to manage. Question 6. The performance metrics show a significant increase in query response times for a critical financial reporting application, impacting the ability to generate end-of-day reports within the required SLA. Which of the following diagnostic steps would be the most appropriate initial action to take to identify the root cause of this performance degradation? Option A. Analyze the DB2 explain output for the slowest executing queries identified by the monitoring tools and correlate with system resource utilization metrics. Option B. Immediately increase the size of all buffer pools and log buffer to their maximum configured values. Option C. Reorganize all tables and indexes in the affected database to ensure optimal data structure. Option D. Disable all application-level caching mechanisms to reduce potential contention. The correct answer is B. Immediately increase the size of all buffer pools and log buffer to their maximum configured values. Explanation. The performance metrics show a significant increase in query response times for a critical financial reporting application. This scenario is professionally challenging because the DBA must quickly identify the root cause of the performance degradation without disrupting the production environment, especially given the sensitive nature of financial data and the potential for regulatory scrutiny if reporting is delayed or inaccurate. The urgency is amplified by the need to maintain data integrity and comply with financial reporting deadlines. The correct approach involves a systematic, non-intrusive impact assessment. This means leveraging DB2 built-in monitoring tools and diagnostic features to gather detailed information about query execution plans, resource utilization, CPU, I/O, memory, and locking activity. The DBA should analyze historical performance data to establish a baseline and then compare it with current metrics. This allows for the identification of specific queries or application patterns that are contributing to the slowdown. The professional best practice here is to prioritize data-driven analysis and to implement changes incrementally with thorough testing in a non-production environment to minimize risk. This aligns with general IT best practices for change management and risk mitigation, which are implicitly expected in regulated environments to ensure system stability and compliance. An incorrect approach would be to immediately implement broad, system-wide changes without a clear understanding of the cause. For instance, indiscriminately increasing buffer pool sizes or altering configuration parameters without evidence of their necessity could lead to unintended consequences, such as increased memory pressure or suboptimal resource allocation, potentially worsening performance or causing instability. This approach fails to demonstrate due diligence and could be seen as a violation of professional responsibility to manage systems effectively and avoid introducing new risks. Another incorrect approach is to rely solely on anecdotal evidence or user complaints without verifying them with objective performance data. While user feedback is important, it should be a starting point for investigation, not the sole basis for action. Acting on assumptions without data can lead to misdiagnosis and wasted effort, potentially delaying the resolution of the actual problem and impacting business operations. This lack of a data-driven methodology is professionally unsound and could lead to compliance issues if the performance degradation affects regulatory reporting. Finally, making drastic changes to the database schema or indexing strategy without a thorough impact analysis and testing is also an unacceptable approach. Such changes can have far-reaching consequences on application functionality and performance, and without proper assessment, they could introduce new, more severe problems. This demonstrates a failure to adhere to sound database administration principles and a disregard for the potential impact on the business and its regulatory obligations. The professional reasoning process should involve 1. Acknowledging the urgency and potential business impact. 2. Utilizing diagnostic tools to gather objective performance data. 3. Formulating hypotheses based on the data. 4. Testing hypotheses in a controlled environment. 5. Implementing changes incrementally and monitoring their effect. 6. Documenting all findings and actions. This systematic approach ensures that decisions are informed, risks are managed, and the integrity of the system and its data is maintained, which is paramount in any regulated industry. Question 7. The audit findings indicate that recent configuration changes to the IBM DB2 one database server may have introduced vulnerabilities affecting data integrity and availability. As the lead DBA, what is the most appropriate immediate course of action to address these findings? Option A. Conduct a thorough impact assessment of each configuration change, prioritizing those with the highest potential risk to data integrity and availability, and develop a targeted remediation plan. Option B. Advise the audit team that the findings are likely false positives and no action is required at this time. Option C. Implement a system-wide patch without fully understanding its specific interaction with the existing configuration. Option D. Immediately revert all recent configuration changes to their previous stable state to eliminate any potential issues. Correct answer is A. Conduct a thorough impact assessment of each configuration change, prioritizing those with the highest potential risk to data integrity and availability, and develop a targeted remediation plan. Explanation. The audit findings indicate a potential impact on data integrity and availability due to recent configuration changes in the DB2 environment. This scenario is professionally challenging because it requires the DBA to balance the immediate need to address audit findings with the potential disruption of ongoing business operations. The pressure to rectify issues quickly can lead to hasty decisions that might introduce new problems or fail to address the root cause effectively. Careful judgment is paramount to ensure that any remediation actions are both effective and minimally disruptive. The correct approach represents best professional practice because it prioritizes a systematic and documented impact assessment. This aligns with general IT governance principles and the implicit requirement for due diligence in managing critical database systems. By thoroughly analyzing the potential consequences of proposed changes, the DBA ensures that solutions are well considered, risks are mitigated, and stakeholders are informed. This proactive and analytical approach minimizes the likelihood of further incidents, maintains data integrity, and supports business continuity, all of which are fundamental responsibilities of a DBA. While specific regulations for DB2 one DBA for LUW in a particular jurisdiction are not explicitly stated in the prompt, the principles of responsible IT management and data stewardship are universally applicable and implicitly expected in any professional context. An incorrect approach that involves immediately reverting all recent changes without understanding their specific impact is professionally unacceptable. This is because it fails to differentiate between changes that may have caused the issues and those that are benign or even beneficial. Such a broad brush approach can lead to unnecessary downtime, loss of functionality, and a failure to address the actual root cause, potentially leaving the system vulnerable to future issues. It demonstrates a lack of analytical rigor and can erode stakeholder confidence. Another incorrect approach, which is to implement a quick fix without proper testing or documentation, is also professionally unacceptable. This bypasses essential quality assurance steps, increasing the risk of introducing new, unforeseen problems. The lack of documentation makes it difficult to track the changes, troubleshoot future issues, or revert if necessary, violating principles of good change management and auditability. A third incorrect approach, which is to ignore the audit findings and assume they are false positives, is the most egregious failure. This demonstrates a dereliction of duty and a disregard for established audit processes. It leaves the organization exposed to data integrity and availability risks, potentially leading to significant financial and reputational damage. It directly contravenes the professional obligation to maintain the health and security of the database systems. The professional reasoning process for similar situations should involve a structured approach. First, thoroughly understand the audit findings and the specific changes made. Second, conduct a detailed impact assessment of each change, considering its effect on data integrity, availability, performance, and security. Third, prioritize remediation actions based on the severity of the impact and the urgency of the audit findings. Fourth, develop and document a clear plan for implementing the chosen solution, including rollback procedures. Fifth, communicate the plan and potential impacts to relevant stakeholders. Finally, execute the plan, monitor the system closely, and document all actions taken. This systematic process ensures that decisions are informed, risks are managed, and professional standards are upheld. Question 8. Regulatory review indicates that a new data privacy regulation is being enacted, requiring stricter controls over the handling and protection of personally identifiable information, PI, stored within IBM DB2 one databases. As the lead DB2 DBA, what is the most appropriate initial step to ensure compliance with this new regulation? Option A. Conduct a comprehensive impact assessment to identify all PII data elements, assess current security controls, and evaluate potential changes needed in database design, access, and auditing. Option B. Begin a phased rollout of application code changes to enforce data access policies at the application layer. Option C. Initiate a review of existing database backup and recovery procedures to ensure they meet the regulation's data retention requirements. Option D. Immediately implement broad data masking across all tables to prevent any unauthorized access to sensitive data. Correct answer is A. Conduct a comprehensive impact assessment to identify all PII data elements, assess current security controls, and evaluate potential changes needed in database design, access, and auditing. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 DBAs, balancing the need for system performance and availability with the imperative to comply with evolving regulatory requirements. The introduction of a new data privacy regulation necessitates changes to how sensitive data is handled and protected within the DB2 database. The professional challenge lies in accurately assessing the impact of these regulatory changes on the existing database infrastructure, applications, and operational procedures without causing undue disruption or compromising data integrity. The DBA must navigate technical complexities, potential business implications, and the strict timelines often associated with regulatory compliance. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously analyzes the regulatory requirements against the current DB2 environment. This includes identifying all database objects, data types, and access patterns that fall under the purview of the new regulation. It requires evaluating the effectiveness of existing security controls, auditing mechanisms, and data masking or encryption strategies. The assessment should also consider the performance implications of any proposed remediation steps, such as implementing new indexing, partitioning, or data archiving strategies. This thorough, systematic, and documented approach ensures that all aspects of the regulation are addressed, risks are mitigated, and the implemented solutions are both compliant and technically sound, aligning with best practices for data governance and regulatory adherence. Incorrect approach is analysis. Implementing changes based solely on a high-level understanding of the regulation without a detailed technical impact assessment is a significant regulatory and ethical failure. This approach risks overlooking critical data elements or processes, leading to non-compliance and potential legal repercussions. It also fails to account for performance degradation or unintended consequences on application functionality, which can impact business operations. Adopting a wait-and-see attitude or delaying the assessment until closer to the compliance deadline is another regulatory failure. This reactive stance increases the likelihood of rushed, suboptimal solutions and can result in significant penalties for non-compliance. It demonstrates a lack of proactive risk management and a disregard for the organization's legal obligations. Focusing only on immediate security patches without considering the broader data handling and lifecycle requirements of the regulation is insufficient. While security is a component, the regulation likely encompasses data retention, access logging, and data subject rights, which would be missed by such a narrow focus. This leads to partial compliance and continued regulatory risk. Professional reasoning. Professionals should adopt a structured, risk-based approach to regulatory impact assessments. This involves 1. Understanding the regulatory landscape, thoroughly reading and interpreting the specific requirements of the regulation. 2. Inventory and analysis, cataloging all relevant database assets and data flows. 3. Gap analysis, comparing current state against regulatory requirements. 4. Impact evaluation, assessing technical, operational, and business implications of identified gaps. 5. Solution design and implementation, developing and deploying compliant solutions. 6. Validation and monitoring, verifying compliance and establishing ongoing monitoring. This systematic process ensures that all facets of the regulation are addressed, risks are managed effectively, and the organization maintains a strong compliance posture. Question 9. Governance review demonstrates that a critical IBM DB2 LUW database supporting core financial transactions is scheduled for an upgrade to a new fix pack. The DBA team has limited time before the scheduled maintenance window and needs to ensure the upgrade proceeds smoothly with minimal disruption. What is the most prudent approach to assess the potential impact of this upgrade? Option A. Conduct a phased, risk-based impact assessment, prioritizing testing of critical transactions, high-volume queries, and key application integrations to identify potential performance bottlenecks and availability issues. Option B. Focus exclusively on testing the application's user interface and core business logic to confirm functional correctness after the upgrade, without specific database performance testing. Option C. Proceed with the upgrade immediately during the maintenance window, relying on the vendor's assurances of backward compatibility and assuming no significant issues will arise. Option D. Implement a full-scale, exhaustive performance test covering every single database object and query before the upgrade, regardless of the time constraints. The correct answer is A. Conduct a phased, risk-based impact assessment, prioritizing testing of critical transactions, high-volume queries, and key application integrations to identify potential performance bottlenecks and availability issues. Explanation. Scenario analysis. This scenario presents a common challenge in database administration where a critical system upgrade is planned, but the impact on performance and availability is not fully understood. The professional challenge lies in balancing the need for modernization and improved functionality with the imperative to maintain business continuity and meet service-level agreements, SLAs. The DBA must make informed decisions without the luxury of extensive, time-consuming testing, which could delay the upgrade and expose the organization to security vulnerabilities or missed opportunities. The pressure to deliver a timely upgrade while mitigating risks requires a robust impact assessment methodology. Correct approach analysis. The correct approach involves a phased, risk-based impact assessment. This methodology prioritizes understanding the potential consequences of the upgrade on key performance indicators, KPI, and critical business functions. It involves identifying high-risk areas, such as heavily trafficked tables, complex queries, or integrations with other systems, and conducting targeted testing on these components. This approach is best professional practice because it aligns with the principles of responsible IT governance and risk management. By focusing on critical elements first, the DBA can identify and address potential issues proactively, minimizing disruption and ensuring compliance with internal policies and external regulations that mandate system availability and data integrity. This methodical approach allows for informed decision-making regarding rollback strategies and contingency planning, thereby safeguarding business operations. Incorrect approach is analysis. Implementing the upgrade without any impact assessment is a direct violation of due diligence and risk management principles. This approach creates an unacceptable level of risk, potentially leading to system outages, data corruption, and significant financial losses. It fails to uphold the ethical responsibility of a DBA to protect the integrity and availability of the data and systems entrusted to them. Such an action could also contravene regulatory requirements that mandate business continuity and disaster recovery planning, exposing the organization to penalties and reputational damage. Performing a comprehensive, full-scale performance test on every aspect of the database before the upgrade, while seemingly thorough, is often impractical and inefficient. This approach can lead to significant delays in the upgrade process, potentially missing critical maintenance windows or delaying the deployment of new features that could benefit the business. While thoroughness is important, an overly broad testing strategy can become a bottleneck, demonstrating a lack of strategic prioritization and resource management. This can indirectly impact the organization's ability to adapt to market changes or meet regulatory deadlines that depend on system upgrades. Focusing solely on application functionality testing without considering database performance implications is another failure. While application functionality is crucial, a database upgrade can have profound effects on query execution times, transaction throughput, and resource utilization. Neglecting these aspects can lead to performance degradation that cripples the application, even if the application's code itself functions correctly. This oversight demonstrates a lack of understanding of the interconnectedness of application and database layers, and can lead to performance issues that are difficult and time-consuming to diagnose and resolve post-upgrade, potentially violating SLAs. Professional reasoning. Professionals should approach impact assessment by first understanding the business criticality of the systems and data they manage. This involves engaging with stakeholders to identify key business processes and their dependencies on the database. The next step is to identify potential risks associated with the proposed change, considering factors like performance, availability, security, and data integrity. A risk-based testing strategy should then be developed, prioritizing the most critical components and scenarios. This allows for efficient allocation of resources and timely identification of potential issues. Finally, a clear rollback plan and contingency measures should be established before proceeding with any significant changes. This structured approach ensures that decisions are data-driven, risks are managed effectively, and business objectives are met. Question 10. Operational review demonstrates that a critical application's query performance has degraded significantly over the past quarter, leading to user complaints and potential business impact. The primary bottleneck appears to be slow response times for a set of frequently executed select statements that join multiple large tables. The database administrator, DBA, has been asked to resolve this issue promptly. Which of the following approaches represents the most professional and effective method for addressing this performance degradation, adhering to best practices for database management and change control? Option A. Implement A database-wide statistics refresh for all tables in the database, assuming outdated statistics are the most probable cause, and monitor performance without further investigation. Option B. Analyze the execution plans for the problematic queries using DB2 tools, examine current database statistics, and review system resource utilization to identify the root cause of the performance issue before proposing and testing any solutions. Option C. Immediately create a new composite index on the most frequently joined columns in the production database, based on the DBA's experience with similar past issues, to expedite query execution. Option D. Advise the application development team to rewrite the application code to use subqueries instead of joins for the affected queries, as subqueries are often faster. The correct answer is C. Immediately create a new composite index on the most frequently joined columns in the production database, based on the DBA's experience with similar past issues, to expedite query execution. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and availability, especially in a production environment. The DBA is tasked with improving query performance for a critical application. The challenge lies in selecting and implementing a solution without negatively impacting ongoing business operations or violating established data governance policies. The need for a quick resolution adds pressure, potentially leading to hasty decisions. Correct approach analysis. The correct approach involves a thorough, phased methodology that prioritizes understanding the root cause of the performance issue before implementing a solution. This includes detailed analysis of query execution plans, workload patterns, and system resource utilization. Implementing changes in a controlled manner, starting with a development or test environment, followed by a staging environment, and finally a carefully planned production rollout with rollback procedures, is crucial. This aligns with best practices for change management and risk mitigation in IT operations, specifically for DB2 1. This would involve leveraging tools like the DB2 Explain facility, monitoring tools e.g. DB2 Snapshot Monitoring, DB2 PD, and performance views to diagnose issues related to indexing, statistics, query optimization, or resource contention. The regulatory framework for IT operations, while not explicitly detailed in the exam syllabus as a specific country's law, generally mandates due diligence, risk management, and adherence to established operational procedures to ensure system stability and data integrity. This phased approach minimizes the risk of introducing new problems, causing downtime, thereby upholding the implicit regulatory and ethical obligation to maintain service levels and protect data. Incorrect approaches analysis. Implementing a new index directly in the production environment without prior analysis or testing is a significant regulatory and ethical failure. It bypasses essential risk assessment and change control processes, potentially leading to performance degradation, locking issues, or even data corruption if the index is inappropriate or conflicts with existing structures. This violates the implicit duty of care to maintain system stability. Modifying the application code to force specific query paths without understanding the underlying data distribution or DB2 optimizer capabilities is another failure. This approach ignores the database's inherent intelligence and can lead to suboptimal performance in different scenarios or when data characteristics change. It also introduces complexity and potential maintenance issues within the application layer, which is outside the DBA's primary domain of control and optimization. Relying solely on anecdotal evidence or user complaints without empirical data to guide the solution is unprofessional and ethically questionable. It leads to reactive, rather than proactive, problem solving, and can result in wasted effort or the implementation of ineffective solutions, failing to meet the obligation to provide reliable and efficient database services. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This involves 1. Problem identification and scoping. Clearly define the issue and its impact. 2. Data gathering and analysis. Collect relevant metrics and logs and use diagnostic tools to understand the root cause. 3. Solution design and evaluation. Propose potential solutions, assess their pros and cons, and consider their impact on the system and business. 4. Testing and validation. Test solutions in non-production environments to confirm effectiveness and identify unintended consequences. 5. Controlled implementation. Plan and execute changes in production with rollback capabilities. 6. Monitoring and verification. Continuously monitor the system post-implementation to ensure the solution is effective and stable. This systematic approach ensures informed decision-making, minimizes risk, and upholds professional standards. Question 11. Implementation of a critical performance tuning strategy for a high-volume transactional database requires immediate attention due to user-reported slowdowns. The DBA has identified a potential indexing issue, but is under pressure to resolve the problem before the end of the business day. What is the most professional and compliant approach to address this situation? Option A. Immediately create the proposed index in the production database, as the risk of continued performance degradation outweighs the potential risks of a direct change. Option B. Apply a generic set of performance tuning scripts that have been known to improve performance in other DB2 environments, without specific analysis of the current bottleneck. Option C. Develop a comprehensive plan including testing the proposed index in a staging environment, documenting the changes, and submitting a change request for approval through the established change management process before production deployment. Option D. Inform management that the issue cannot be resolved within the business day, and recommend scheduling a maintenance window for the next available opportunity, without proposing a specific solution yet. The correct answer is A. Immediately create the proposed index in the production database, as the risk of continued performance degradation outweighs the potential risks of a direct change. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and availability, especially in a production environment. The DBA must consider the potential impact of changes on ongoing business operations, the risk of data corruption, and the adherence to established change management protocols. The pressure to resolve performance issues quickly can lead to hasty decisions that bypass necessary testing or approval processes, creating significant operational and compliance risks. Correct approach analysis. The correct approach involves a systematic and controlled process for implementing performance tuning changes. This includes thorough analysis of the performance bottleneck, development of a specific tuning strategy, e.g., index creation, query optimization, parameter adjustment, rigorous testing in a non-production environment that mirrors production as closely as possible, and obtaining formal approval through the established change management process. This methodology ensures that the proposed changes are effective, do not introduce new problems, and comply with organizational policies and potentially regulatory requirements for system stability and data integrity. Adhering to these steps minimizes the risk of downtime, data loss, and unauthorized system modifications, which are critical for maintaining business continuity and trust. Incorrect approaches analysis. Implementing performance tuning changes directly in the production environment without prior testing or approval is a significant regulatory and ethical failure. This bypasses critical quality assurance steps, increasing the risk of unintended consequences such as system outages, data corruption, or performance degradation. Such actions violate principles of responsible system management and can lead to breaches of service level agreements, SLAs, and potentially noncompliance with data governance policies. Applying a generic performance tuning script without understanding the specific cause of the bottleneck is also professionally unacceptable. This approach is akin to treating symptoms without diagnosing the disease. It is inefficient, may not address the root cause, and could introduce new issues or negatively impact other areas of the database. This demonstrates a lack of analytical rigor and a failure to apply best practices in problem solving. Ignoring the change management process and implementing changes unilaterally, even if tested, is a procedural and ethical lapse. Change management exists to ensure that all stakeholders are aware of and approve modifications to critical systems, mitigating risks, and ensuring alignment with business objectives. Circumventing this process undermines organizational control and accountability. Professional reasoning. Professionals should approach performance tuning by first establishing a clear understanding of the problem through monitoring and diagnostics. This should be followed by developing a targeted solution, which must then be validated in a test environment. The change management process serves as a crucial gatekeeper, ensuring that all proposed changes are reviewed, approved, and scheduled appropriately. This structured approach, emphasizing analysis, testing, and controlled implementation, is fundamental to maintaining system stability, data integrity, and operational efficiency, while also adhering to professional standards and organizational policies. Question 12. Cost-benefit analysis shows that implementing a new performance-critical application on the existing DB2 1 LUW environment, which is already operating at high resource utilization, presents a significant challenge. The application is expected to increase transaction volume and data processing demands substantially. What is the most prudent and professionally responsible approach to ensure successful deployment without jeopardizing existing critical services? Option A. Implement the application directly into the production environment, relying on the application developer's assurances of its efficiency and monitoring closely for immediate issues. Option B. Conduct a thorough performance analysis and tuning of the existing DB2 instance and application code in a dedicated, production-like test environment, followed by a phased pilot deployment in production. Option C. Immediately recommend a significant hardware upgrade for the entire DB2 server infrastructure to accommodate the anticipated load increase. Option D. Focus solely on optimizing the application's SQL queries and stored procedures, assuming that database and system-level configurations are already at their optimal state. The correct answer is A. Implement the application directly into the production environment, relying on the application developer's assurances of its efficiency and monitoring closely for immediate issues. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 DBAs, balancing performance optimization with resource constraints and potential operational risks. The need to implement a new, performance-critical application on an existing DB2 1 LUW environment, which is already experiencing high resource utilization, creates a complex decision-making landscape. The DBA must consider not only the technical feasibility, but also the potential impact on existing services, the cost of remediation, and the adherence to best practices for system stability and data integrity. The pressure to deliver the new application quickly, coupled with the existing system's limitations, necessitates a thorough and risk-aware approach. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes thorough testing and validation in a controlled environment before deploying to production. This aligns with the principles of responsible system administration and risk management. Specifically, creating a dedicated test environment that mirrors the production configuration, including data volume and workload characteristics, allows for accurate performance benchmarking and identification of potential bottlenecks. Implementing the application in a development or staging environment first, followed by a pilot deployment on a subset of production resources or during off-peak hours, provides a gradual transition and minimizes the risk of widespread disruption. This methodical approach ensures that the application's performance and resource demands are fully understood and managed, preventing unforeseen impacts on existing critical systems. This is best professional practice as it upholds the DBA's responsibility to maintain system stability, data integrity, and service availability, all of which are implicitly governed by operational guidelines and service-level agreements that are standard in professional IT environments. Incorrect approaches analysis. An approach that bypasses rigorous testing and directly deploys the application to the production environment, assuming it will perform adequately, represents a significant regulatory and ethical failure. This demonstrates a disregard for established IT governance principles, which mandate controlled deployments to mitigate risks. Such an action could lead to system instability, data corruption, or service outages, violating implicit service-level agreements and potentially leading to financial or reputational damage for the organization. This is ethically unsound as it prioritizes speed over reliability and safety. Another incorrect approach would be to immediately recommend hardware upgrades without a comprehensive analysis of the application's actual resource needs and potential for optimization within the existing infrastructure. While hardware upgrades might seem like a straightforward solution, they are often costly and may not address underlying inefficiencies in the application or database configuration. This approach fails to demonstrate due diligence and a commitment to cost-effectiveness, which are professional expectations. It also risks over-provisioning resources, leading to unnecessary expenditure. Finally, an approach that focuses solely on application-level tuning without considering the underlying DB2 1 LUW configuration and operating system parameters is incomplete. DB2 performance is a complex interplay of application code, database design, instance configuration, and system resources. Neglecting any of these aspects can lead to suboptimal results and potential instability. This demonstrates a lack of holistic understanding and a failure to apply comprehensive diagnostic and tuning methodologies expected of a senior DBA. Professional reasoning. Professionals should adopt a structured problem-solving framework. This involves understanding the business requirements, assessing the current environment's capabilities and limitations, identifying potential risks, and developing a phased plan that includes thorough testing, validation, and controlled deployment. The decision-making process should be data-driven, relying on performance metrics and impact analysis. When faced with resource constraints and performance demands, the professional approach is to explore all optimization avenues, including application tuning, database configuration adjustments, and, as a last resort, infrastructure upgrades, all within a controlled and validated process. This ensures that decisions are informed, risks are managed, and the organization's assets are utilized efficiently and effectively. Question 13. Operational review demonstrates a significant increase in application response times for critical database transactions over the past week. Users report intermittent delays, and system logs show an uptick in lock-wait events. The database is a high-availability OLP system with minimal tolerance for downtime. The DBA needs to identify the root cause and implement a solution efficiently and safely. Option A. Analyze snapshot monitor output for buffer pool hit ratios, lock wait times, and I/O statistics, and use DB2 PD to investigate active lock holders and their associated SQL statements before proposing any changes. Option B. Assume the issue is network latency and instruct the network team to perform a full network diagnostic sweep. Option C. Immediately increase the size of the buffer pools and reorganize all heavily used tables to reduce fragmentation, then monitor for improvements. Option D. Initiate a full database backup, and then proceed with a series of random parameter tuning experiments to observe their impact on response times. The correct answer is C. Immediately increase the size of the buffer pools and reorganize all heavily used tables to reduce fragmentation, then monitor for improvements. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 DBAs, balancing performance optimization with data integrity and availability, especially in a production environment where downtime is costly. The core difficulty lies in identifying the root cause of performance degradation without introducing further risk or impacting ongoing business operations. A hasty or incorrect approach can lead to data corruption, extended outages, or missed critical performance windows. The DBA must possess a deep understanding of DB2 internals, monitoring tools, and the application's workload characteristics. Correct approach analysis. The correct approach involves a systematic, data-driven investigation. This begins with leveraging DB2 built-in monitoring tools, e.g., snapshot monitors, event monitors, and diagnostic utilities, e.g., DB2 PD, DB2 Expl, to gather baseline performance metrics and identify specific areas of contention. Analyzing these metrics in the context of the application's known workload patterns allows for targeted troubleshooting. For instance, identifying high lock weights might point to inefficient queries or transaction design, while high buffer pool usage might indicate insufficient memory allocation or suboptimal buffer pool configuration. The key is to isolate the problem, hypothesize potential causes, and then test those hypotheses with minimal impact, often during scheduled maintenance windows or by using non-disruptive diagnostic techniques. This aligns with best practices for system administration, emphasizing proactive monitoring, root cause analysis, and controlled incremental changes. Incorrect approaches analysis. One incorrect approach would be to immediately implement aggressive tuning parameters without understanding the underlying cause. For example, drastically increasing buffer pool sizes without analyzing buffer pool hit ratios, and I/O patterns could lead to excessive memory consumption, paging, and overall system instability, potentially violating principles of resource management and system stability. Another incorrect approach would be to randomly reorganize tables or indexes based on perceived slowness without analyzing their fragmentation levels or usage statistics. This could lead to unnecessary I/O, locking contention during the reorganization process, and potentially degrade performance if the reorganization is not beneficial. A third incorrect approach would be to assume the issue is hardware-related and escalate to system administrators without first exhausting database-level diagnostic possibilities. This bypasses crucial database-specific troubleshooting steps and can lead to misallocation of resources and delayed resolution. Professional reasoning. Professionals should approach performance issues with a structured methodology. This involves 1. Define the problem, clearly articulate the observed symptoms and their business impact. 2. Gather data, utilize appropriate monitoring and diagnostic tools to collect relevant metrics. 3. Analyze data, correlate observed metrics with known workload patterns and DB2 behavior. 4. Formulate hypotheses, develop plausible explanations for the performance degradation. 5. Test hypotheses, implement targeted changes or diagnostic steps, preferably in a controlled manner. 6. Validate results, measure the impact of changes and confirm resolution. 7. Document, record findings, actions, and outcomes for future reference. This systematic process ensures that solutions are effective, minimize risk, and are based on sound technical reasoning. Question 14. The assessment process reveals that a critical customer-facing application hosted on IBM DB2 one for LUW is experiencing intermittent but significant performance degradation. Users report slow response times during peak hours, impacting business operations. The database contains sensitive customer personally identifiable information, PI. As the lead DBA, you need to diagnose and resolve this issue. Which of the following diagnostic and resolution strategies best adheres to professional best practices and regulatory considerations for data handling? Option A. Request that the application development team rewrite all complex queries to simplify them, without first identifying which specific queries are causing the performance issues. Option B. Immediately implement a series of aggressive, unverified performance tuning parameters across the entire database instance without prior analysis of specific problematic queries or objects. Option C. Analyze the DB2 diagnostic logs and use the explain facility to examine the execution plans of frequently executed or slow-running queries, focusing on identifying inefficient access paths or join methods. Option D. Temporarily disable all database security auditing and access controls to isolate whether security overhead is contributing to the performance bottleneck. The correct answer is D. Temporarily disable all database security auditing and access controls to isolate whether security overhead is contributing to the performance bottleneck. Explanation. The assessment process reveals a common challenge in database administration: balancing performance optimization with data integrity and security, particularly when dealing with sensitive customer information. The professional challenge lies in identifying the root cause of performance degradation without compromising the confidentiality or availability of the data, adhering to strict data handling policies. The correct approach represents best professional practice because it systematically isolates the performance issue to a specific database object or query, allowing for targeted and effective tuning. This method prioritizes understanding the impact of any changes on data integrity and security, aligning with the principle of least privilege and data protection. By analyzing the execution plan and identifying inefficient SQL, the DBA can propose modifications that improve performance without introducing new vulnerabilities or risking data corruption. This aligns with general IT best practices for change management and risk mitigation, ensuring that operational efficiency is achieved responsibly. An incorrect approach that involves immediately disabling security features to test performance would be a significant regulatory and ethical failure. This action directly violates data protection regulations, assuming a jurisdiction with such regulations, e.g., GDPR or similar principles, by exposing sensitive data to unnecessary risk. It demonstrates a disregard for the confidentiality and integrity of customer information, which is a core ethical obligation for any IT professional. Furthermore, it bypasses established security protocols, potentially creating a backdoor for unauthorized access and leading to severe compliance breaches and reputational damage. Another incorrect approach, such as randomly applying performance tuning techniques without proper analysis, is professionally unacceptable due to its inherent risk. This haphazard method can lead to unintended consequences, including performance degradation in other areas, data corruption, or even system instability. It lacks the analytical rigor required for effective database management and demonstrates a failure to apply due diligence. This approach also fails to consider the potential impact on data security and integrity, as changes are made without a clear understanding of their effects. A professional reasoning process for such situations involves a structured, analytical approach. First, clearly define the observed problem and its impact. Second, gather relevant diagnostic information, e.g., performance metrics, system logs, query execution plans. Third, formulate hypotheses about the root cause. Fourth, test hypotheses systematically, prioritizing methods that minimize risk to data integrity and security. Fifth, implement changes incrementally with thorough testing and rollback plans. Finally, document all findings, actions, and outcomes for future reference and auditability. This methodical approach ensures that performance issues are addressed effectively, while upholding professional responsibilities regarding data security and integrity. Question 15. Investigation of a critical database maintenance task involving a table reorganization on a production IBM DB2 one LUW system reveals a potential risk of data corruption or loss. The DBA is considering several methods to mitigate this risk and ensure compliance with data integrity and auditability requirements under U.S. federal regulations, which approach best balances operational efficiency with regulatory adherence. Option A. Perform a full database backup immediately before initiating the table reorganization and ensure the operation is logged in the DB2 audit trail. Option B. Skip the table reorganization entirely due to the perceived risk, opting for manual data cleanup instead. Option C. Execute the table reorganization and then perform a full database backup after the operation is successfully completed. Option D. Proceed with the table reorganization without a backup, relying on the existing database replication to ensure data availability. The correct answer is A. Perform a full database backup immediately before initiating the table reorganization and ensure the operation is logged in the DB2 audit trail. Explanation. This scenario presents a common challenge for DB2 DBAs, ensuring data integrity and availability while adhering to operational best practices and potential regulatory requirements for data retention and auditability. The core difficulty lies in balancing the need for efficient storage and performance with the imperative to maintain accurate historical records for potential audits or compliance checks. The specific jurisdiction for this exam is U.S. federal regulations as they apply to database administration. The correct approach represents best professional practice because it directly addresses the potential for data loss or corruption during a critical maintenance operation. By performing a full backup before initiating the reorg, the DBA creates a recovery point. This aligns with general IT best practices for disaster recovery and business continuity, which are often implicitly or explicitly mandated by regulatory frameworks requiring data resilience. Furthermore, the decision to log the operation in the system's audit trail ensures transparency and accountability, crucial for compliance with regulations like SOX, Sarbanes-Oxley Act, if the data is financial in nature, or HIPAA if it pertains to health information, both of which necessitate auditability of system changes. An incorrect approach that skips the backup before the reorg fails to meet the fundamental professional obligation of safeguarding data. This could lead to irreversible data loss if the reorg process encounters an unrecoverable error, violating principles of due diligence and potentially breaching data protection regulations that require reasonable measures to prevent data loss. Another incorrect approach that fails to document the reorg in the audit trail undermines the principle of accountability. Many regulations, particularly those concerning financial reporting or sensitive personal data, require a clear and verifiable record of all system modifications. Omitting this documentation leaves the organization vulnerable to accusations of attempting to conceal changes, which is a serious ethical and regulatory breach. A third incorrect approach that relies solely on replication without a full backup before a destructive operation like a reorg is also flawed. While replication provides redundancy, it is not a substitute for a point-in-time backup. Replication typically mirrors the current state, and if corruption occurs during the reorg, the replicated data could also become corrupted, or the replication process itself might fail, leaving no reliable recovery option. The professional reasoning process for a DBA in such a situation should involve a risk assessment. First, identify the critical operation and its potential impact on data integrity and availability. Second, Consult relevant internal policies and external regulatory requirements concerning data backup, retention, and auditability. Third, evaluate available mitigation strategies, such as backups, replication, and logging. Fourth, select the strategy that provides the highest level of data protection and compliance assurance with the least disruption. In this case, a full backup before a potentially disruptive operation, coupled with comprehensive logging, offers the most robust protection and meets the highest professional and regulatory standards. Question 16. What factors determine the most appropriate strategy for applying a DB2 one fix pack to a production environment to ensure minimal disruption to critical business operations? Option A. The perceived urgency of the fix pack, as communicated by the vendor without extensive validation. Option B. The immediate availability of system administrators to monitor the deployment process. Option C. The thoroughness of pre-deployment testing in a representative non-production environment and the existence of a well-defined rollback plan. Option D. The total number of database objects within the instance, regardless of their criticality. The correct answer is C. The thoroughness of pre-deployment testing in a representative non-production environment and the existence of a well-defined rollback plan. Explanation. This scenario presents a common challenge for DB2 DBAs, ensuring data integrity and availability while managing the impact of system maintenance. The professional challenge lies in balancing the need for routine patching and updates with the critical requirement of uninterrupted database service for business operations. A misstep can lead to data corruption, extended downtime, and significant financial or reputational damage. Careful judgment is required to select a maintenance strategy that minimizes risk and disruption. The correct approach prioritizes a phased, controlled rollout of the DB2 one fix pack. This involves thorough testing in a non-production environment that closely mirrors the production setup, including data volume, workload, and configuration. Following successful testing, a carefully planned deployment to production, ideally during a low-usage window, with robust rollback procedures in place, represents best professional practice. This aligns with general IT best practices for change management and risk mitigation, which are implicitly supported by the need for reliable database services in any regulated industry. While specific DB2 one regulations are not provided, the principle of minimizing disruption to critical systems is a universal professional standard. An incorrect approach would be to apply the fix pack directly to the production environment without prior testing. This is professionally unacceptable because it introduces a high risk of unforeseen issues, such as compatibility problems with applications, performance degradation, or outright system failure, leading to extended and unplanned downtime. This directly violates the implicit professional obligation to maintain system stability and data integrity. Another incorrect approach would be to postpone the fix pack indefinitely due to fear of disruption. While caution is warranted, neglecting essential updates can leave the database vulnerable to security exploits or performance bottlenecks that could be more detrimental in the long run than a planned maintenance window. This demonstrates a failure in proactive system management and risk assessment. Finally, applying the fix pack during peak business hours without adequate testing or rollback plans is also professionally unsound. This significantly increases the likelihood of impacting critical business processes and user productivity, leading to direct financial losses and customer dissatisfaction. The professional reasoning process for similar situations should involve a comprehensive risk assessment. This includes understanding the potential impact of the fix pack, the criticality of the database systems, the available testing environments, and the organization's tolerance for downtime. A structured change management process, including detailed planning, testing, communication, and rollback strategies, is essential. The decision should always favor a method that demonstrably minimizes risk to data integrity and service availability, while still addressing the need for system maintenance. Question 17. When evaluating potential performance enhancements for a critical production DB2 one database, which approach best balances the need for immediate improvement with the imperative of safeguarding data integrity and ensuring operational continuity? Option A. Perform a full backup of the database, then test the proposed configuration changes in a staging environment that mirrors production, and if successful, schedule a maintenance window to apply the changes to production. Option B. Proceed with the configuration changes on the production system, relying on the database's inherent recovery mechanisms to address any unforeseen issues that may arise. Option C. Prioritize the implementation of changes that show the most significant potential performance gains in online benchmarks, deferring any data integrity checks until after the changes are live. Option D. Immediately implement the proposed configuration changes directly on the production system, monitoring performance metrics closely to gauge the impact. The correct answer is D. Immediately implement the proposed configuration changes directly on the production system, monitoring performance metrics closely to gauge the impact. Explanation. The scenario presents a common challenge for DB2 DBAs, ensuring data integrity and availability while managing system resources and adhering to operational policies. The core of the challenge lies in balancing the immediate need for performance tuning with the long-term implications of data corruption or loss, especially in a regulated environment where auditability and recovery are paramount. The DBA must make a judgment call that prioritizes safety and compliance without unduly hindering operational efficiency. The correct approach represents best professional practice because it systematically addresses potential data corruption risks before implementing performance-enhancing changes. This aligns with the principle of do no harm in database administration. By first backing up critical data and verifying its integrity, the DBA establishes a safety net. Subsequently, testing changes in a non-production environment allows for the identification of unintended consequences without impacting live operations. This methodical, risk-averse strategy is crucial for maintaining data integrity and ensuring business continuity, which are often implicitly or explicitly mandated by operational guidelines and potentially by broader regulatory frameworks concerning data protection and availability, even if not explicitly detailed in the exam-specific jurisdiction. The emphasis on verification and controlled rollout demonstrates a commitment to robust data management practices. An incorrect approach that bypasses backup procedures before making significant configuration changes is professionally unacceptable due to the inherent risk of data loss or corruption. This failure to implement a fundamental data protection measure directly violates best practices for database administration and could lead to irretrievable data loss, impacting business operations and potentially violating data retention or availability requirements. Another incorrect approach, which involves applying changes directly to the production environment without prior testing, demonstrates a disregard for system stability and data integrity. This reckless action significantly increases the likelihood of introducing errors or performance degradation that could disrupt critical business functions and compromise data availability. A third incorrect approach, focusing solely on performance metrics without considering the underlying data structures or potential side effects, overlooks the interconnectedness of database components and can lead to superficial improvements that mask deeper issues or introduce new vulnerabilities. Professionals should approach such situations by adopting a structured problem-solving framework. This involves 1. Understanding the objective performance improvement, 2. Identifying potential risks, data corruption, system instability, 3. Developing a mitigation plan, backups, testing, 4. Executing the plan in a controlled manner, 5. Verifying the results, 6. Documenting the process and outcomes. This systematic approach ensures that decisions are informed, risks are managed, and the integrity of the database and its data are preserved. Question 18. The efficiency study reveals that a critical DB2 one LUW database application is experiencing intermittent but severe performance degradation, impacting user experience and transaction processing times. The DBA team suspects that inefficient query execution is a primary contributor. To address this, they are considering several diagnostic and remediation strategies. Which strategy best balances the need for accurate root cause analysis with the imperative to maintain database stability and data integrity? Option A. Immediately implement a broad set of database configuration parameter changes, such as increasing buffer pool sizes and adjusting lock timeouts based on general performance tuning best practices. Option B. Temporarily disable all database logging to reduce I/O overhead, with the intention of re-enabling it once performance has improved. Option C. Proactively rebuild all indexes on the most frequently accessed tables, assuming that index fragmentation is the most likely cause of the performance issues. Option D. Conduct a thorough analysis of the application's workload using DB2 snapshot monitors and event monitors to capture detailed statistics on query execution, resource utilization, and lock weights, and then use the explain facility to analyze the execution plans of the slowest queries. The correct answer is A. Immediately implement a broad set of database configuration parameter changes, such as increasing buffer pool sizes and adjusting lock timeouts, based on general performance tuning best practices. Explanation: the efficiency study reveals a significant performance bottleneck in a critical DB2 LUW database application. The challenge lies in identifying the root cause of this performance degradation without disrupting ongoing business operations or violating data integrity principles. A DBA must balance the need for rapid problem resolution with the imperative to maintain a stable and secure database environment. This scenario is professionally challenging because it demands a systematic, evidence-based approach to troubleshooting, requiring deep knowledge of DB2 internals and performance tuning methodologies, while adhering to established operational procedures and potential regulatory compliance requirements related to data availability and integrity. The correct approach represents best professional practice because it prioritizes a non-intrusive analytical method for diagnosing performance issues. By leveraging DB2 built-in diagnostic tools and monitoring capabilities, such as snapshot monitors, event monitors, and the explain facility, the DBA can gather objective data on query execution plans, resource utilization, and lock contention. This data-driven methodology ensures that any proposed solutions are based on actual performance metrics rather than assumptions, minimizing the risk of introducing new problems or negatively impacting other application components. This aligns with professional standards of due diligence and responsible system management. An incorrect approach that involves immediately altering database configuration parameters without a clear understanding of their impact is professionally unacceptable. This could lead to unintended consequences, such as increased resource consumption, deadlocks, or data corruption, potentially violating data integrity and availability mandates. Another incorrect approach, such as randomly optimizing SQL statements without analyzing their execution plans, is inefficient and may not address the actual bottleneck, wasting valuable time and resources. Furthermore, making significant changes to the database schema or indexing strategy without thorough testing and impact analysis could lead to application instability and data loss, which are serious regulatory and ethical failures. The professional decision-making process for similar situations should involve a structured troubleshooting methodology. This includes clearly defining the problem and its scope, gathering relevant diagnostic data using appropriate tools, analyzing the data to identify the root cause, developing and testing potential solutions in a non-production environment, implementing the chosen solution with a rollback plan, and monitoring the system post-implementation to confirm resolution and prevent recurrence. This systematic approach ensures that decisions are informed, risks are mitigated, and the integrity and performance of the database are maintained. Question 19. Market research demonstrates that IBM DB2 for LUW databases are experiencing intermittent but significant performance degradation during peak operational hours. As the lead DBA, you are tasked with diagnosing and resolving this issue. Which of the following approaches best aligns with professional best practices and regulatory compliance for database management? Option A. Analyze current workload patterns and identify specific SQL statements exhibiting high resource consumption or contention. Based on this analysis, propose and test targeted index creations or modifications in a development environment before applying to production. Option B. Focus solely on increasing the memory allocated to the DB2 buffer pool, as this is a common solution for performance issues. Option C. Immediately implement a comprehensive set of new indexes across all frequently accessed tables, assuming that increased indexing will universally improve performance. Option D. Revert the database configuration to a known stable state from a previous week, without performing any detailed analysis of the current performance metrics. The correct answer is A. Analyze current workload patterns and identify specific SQL statements exhibiting high resource consumption or contention. Based on this analysis, Propose and test targeted index creations or modifications in a development environment before applying to production. Explanation. This scenario presents a common challenge for DB2 DBAs, balancing performance tuning with the need for data integrity and adherence to operational policies. The professional challenge lies in identifying the root cause of performance degradation without introducing unintended side effects or violating established procedures. Careful judgment is required to select an approach that is both effective and compliant. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation. By first analyzing the current workload and identifying specific SQL statements causing contention, the DBA can then target the most impactful areas for optimization. This aligns with the principle of least privilege in minimizing disruption, ensuring that changes are justified and their effects are understood. Furthermore, this methodical approach supports auditability and troubleshooting, as it creates a clear record of the problem and the steps taken to resolve it. Adhering to change management processes, even for seemingly minor tuning activities, is crucial for maintaining system stability and preventing unauthorized modifications. An incorrect approach that involves immediately implementing broad, unverified indexing strategies is professionally unacceptable. This violates the principle of do no harm by potentially introducing new performance bottlenecks or increasing storage overhead without a clear understanding of the impact, bypasses the necessary analysis and testing phases, increasing the risk of system instability. Such an action could also be seen as a failure to follow established operational procedures and change control, which are often mandated by internal policies and potentially by regulatory frameworks that require documented and approved system modifications. Another incorrect approach, such as reverting to a previous configuration without proper root cause analysis, is also professionally unsound. While it might temporarily resolve the issue, it fails to address the underlying problem, leaving the system vulnerable to future performance degradation. This reactive approach is inefficient and does not contribute to long-term system health or knowledge acquisition. It also risks losing valuable performance data that could inform future tuning efforts. The professional decision-making process for similar situations should involve a structured problem-solving methodology. This includes 1. Problem identification. Clearly define the observed issue, e.g., slow query response times. 2. Data gathering. Collect relevant metrics, e.g., system performance counters, DB2 snapshot information, workload analysis. 3. Root cause analysis. Analyze the gathered data to pinpoint the source of the problem, e.g., inefficient queries, missing indexes, locking contention. 4. Solution development. Propose potential solutions based on the root cause. 5. Testing and validation. Test proposed solutions in a non-production environment to assess their effectiveness and impact. 6. Implementation. Deploy the validated solution following established change management procedures. 7. Monitoring and verification. Continuously monitor the system to ensure the issue is resolved and no new problems have arisen. Question 20. Operational review demonstrates that critical application queries are experiencing significant latency, impacting end-user experience and potentially violating service-level agreements. As the IBM DB2 1 DBA for LUW, you need to address this performance degradation. Which of the following approaches represents the most professional and risk-averse strategy for performance tuning? Option A. Advise the application development team to rewrite all critical queries to be more efficient, without investigating the database's current state or potential for optimization through database-level changes. Option B. Implement a comprehensive performance tuning strategy that includes analyzing query execution plans, assessing current statistics, testing potential index modifications or additions in a development environment, and developing a rollback plan before production deployment. Option C. Rely solely on automated performance tuning utilities provided by DB2 to identify and implement all necessary optimizations, assuming the tools will always select the best course of action. Option D. Immediately create new indexes on all frequently queried columns identified in the slow queries, without prior analysis of existing indexes or query execution plans. The correct answer is D. Immediately create new indexes on all frequently queried columns identified in the slow queries, without prior analysis of existing indexes or query execution plans. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing performance optimization with data integrity and adherence to established operational procedures. The DBA is tasked with improving query response times, a critical factor for application performance and user satisfaction. However, any changes made must be carefully considered to avoid unintended consequences, such as data corruption, security breaches, or violation of internal policies, and potentially regulatory compliance if data sensitivity is involved. The challenge lies in selecting the most appropriate and least disruptive method for performance tuning within the constraints of the IBM DB2 environment and the organization's governance framework. Correct approach analysis. The correct approach involves a systematic and controlled method of performance tuning that prioritizes data integrity and minimizes risk. This typically includes thorough analysis of query execution plans, understanding the impact of potential changes on the database, and implementing changes in a test environment before deploying to production. For DB2 1, this might involve analyzing statistics, considering index optimization, or reviewing table design. The professional best practice is to leverage DB2 built-in diagnostic tools and follow a change management process that includes rollback procedures. This approach aligns with general IT governance principles, and if the data being managed is subject to specific regulations, e.g., financial, healthcare, ensures that data handling remains compliant by avoiding methods that could compromise audit trails or data accuracy. Incorrect approach is analysis. One incorrect approach would be to immediately implement aggressive indexing strategies or alter table structures without prior analysis or testing. This carries a high risk of performance degradation, locking issues, or even data corruption if not executed perfectly. From a regulatory perspective, such ad hoc changes could violate data integrity requirements if they lead to inconsistencies or loss of data. Another incorrect approach would be to rely solely on automated performance tuning tools without human oversight or understanding of the underlying data and application logic. While these tools can be helpful, they may not always account for specific business rules or long-term data growth patterns, potentially leading to suboptimal or even detrimental changes. Ethically, this demonstrates a lack of due diligence. A third incorrect approach might be to ignore the performance issue altogether, which, while seemingly safe, can lead to significant business impact and potentially violate service-level agreements, SLAs, or regulatory mandates related to data availability and responsiveness. Professional reasoning. Professionals should approach performance tuning with a structured methodology. This involves 1. Understanding the problem. Clearly define the performance issue and its impact. 2. Analysis. Utilize DB2 diagnostic tools, e.g., DB2 Expon, DB2 PD, Monget PKG caches to identify the root cause of the performance bottleneck. 3. Hypothesis and solution design. Formulate potential solutions, e.g., index creation/modification, query rewriting, statistics updates, and assess their potential impact. 4. Testing. Implement proposed solutions in a non-production environment that mirrors production as closely as possible. 5. Deployment. Plan and execute the deployment to production with a clear rollback strategy. 6. Monitoring. Continuously monitor performance after deployment to ensure the desired outcome and detect any new issues. This systematic process ensures that changes are well-informed, controlled, and minimize risk to data integrity and system stability, thereby upholding professional standards and any applicable regulatory requirements.